So we left off right about here yesterday. We started talking about some of these network-based authentication protocols. And then we went into the dial-up-based protocols. And we basically went from clear text into the hash-based and into whatever the vendor feels like writing.
So all those aren't dial-up, right?
No, not necessarily. They started out as dial-up, but they're actually, like, for example, EAPs used in wireless, and it's been extended since then. So it's even extensible authentication protocol.
Well, MD5 is used everywhere.
What is it?
MD5 is used everywhere.
It's very, very common. Because what you're doing here, any type of hash, you're basically taking your password, you're hashing it, you take your output and you send your output over so the password never goes across. So that method of never sending the password across the network is still extremely popular.
So these are really network-based also, right?
Can be, yeah.
I'm just, the dial-up part just, you know.
Although don't focus on that
Because I
part.
have to use dial-up and all that.
Just block out your eyes.
Right.
Don't look at the sun.
I'll block it out.
Because like you could take a Microsoft server and set up what's it called routing and remote access, and you could set up internal connections and actually use CHAP or MS Chat internally if you wanted to as well. So it's not limited to that. Authorization, I gave you a couple keywords for this yesterday. I summarized this in terms of what? First we had identification, then we had authentication, and now we have authorization. So what were your keywords for authorization? How do you know you're being authorized?
Wasn't it
What
prove
you
it?
know.
Or no, prove it is.
That was
What you
your
know, what you
authentication.
are.
Authentication was the prove it factor.
Obviously, this is a little lower on the learning cone.
It's permissions. The read, write, execute,
Right,
delete,
yeah.
full control. So once you prove who you say you are, then I can turn around and say, okay, now that I at least know who I'm talking to, now here's what you can do. Because I know who you are because I proved it, now you can read the file, write to the file, full control, no access, whatever it is, but it's permission based. As opposed to authentication, this is more proving identity. So in this case, we're speaking to performing certain functions on a set of objects in a network. And in most of the case, controlling access through that, read, writing, execute, or permission-based. Well, you could have mandatory access control, you could have discretionary access control, you could have role-based access control or rule-based access control. But it's permissions, again, permissions on the objects, read, write. It could be task-oriented too. And you can break it down in terms of groups, physical, logical, time of day. We'll get more into these types of restrictions, but at this point, it's more the permissions point that I want you to focus on. So, here's what I want you to write down. Single sign-on, I want you to write down single point of failure. That is the biggest concern with single sign-on. Because if I can break in and get your single sign-on password, I can also get every other password on the network. Well, not that I need it because you're using single sign-on, so it's already proxying that request. A good way to look at single sign-on is one database that is in a read-write copy, and then other databases that are in a read-only or import-only copy. Like, for example, on my website, I have a Joomla site, and I have a Moodle site, basically the two separate components. But I use one as the primary or master and then the other one as the slave. And then I replicate the passwords between the two so that you don't have to type in two passwords. But one's in a read-write full control, Joomla is in a read-write full control configuration. Moodle just imports that information. But if somebody wanted to break into that single sign-on, if they get the Joomla password, they automatically get the Moodle password because it's being replicated. So in many cases, it's a single point of failure. So it's nice for let's think of functionality versus security for a second. The network admin versus security. Network admins typically like single sign-on because you can take all of these different systems, mainframes, Unix systems, Windows systems, you name it. You can take all those and use the same password to log into all of them. Security people don't like that idea, because if somebody figures out one password, now instead of getting access to one isolated system, you get access to as many systems as there are in the single sign-on. But in theory, functionality-wise, it's simpler user administration. Now, if you've ever tried to configure single sign-on, you might disagree with that. Possibly a more secure environment. It all depends on the types of hashes that you're using and things like that. And ultimately, could reduce total cost of ownership because of the simplified administration. Kerberos, Sesame are types of single sign-on. Windows can be in certain configurations. Disadvantages can be difficult to implement, and the biggest problem that I've had with single sign-on is the concept of the weakest link in the chain. Anybody want to take a guess what I mean by that?
Yep.
Go ahead.
It's your security. I mean, all the parts of your security give you the overall security. So if you have a weak link like single sign-on, if somebody can access that and break that, then the rest of your
How
security.
about within single sign-on? Since we're replicating here,
Any service, if you have a weak service that has single sign-on, that means you break it the whole
right?
system.
And in some cases, I've had to do single sign-on with legacy systems, and those types of passwords, they didn't have case. So it didn't matter if you used uppercase or lowercase, so it didn't distinguish between them. It only basically did numbers and letters. And so what that does is that one system, I have to downgrade all of the other single sign-on to basically say, don't use case in the password. And so because I had one system that now I had a weak password complexity requirement, now I had to basically duplicate that for the other ones for the sake of compatibility. So basically I had to dumb down the passwords for the whole network, also creating the weakest, or replicating that weakest link.
Well, but there are other ways to get around it.
Can be, yeah. I didn't have to use single sign-on for that one legacy system, but that's the way the designers wanted it.
Well, or you can, where you can set it up where you have a, but you have a system assigned password for that particular item that is authenticated through the single sign-on password.
Yeah. In this case, that wasn't available, but you do have flexibility. Well, as much flexibility as the vendor wants to give you, probably fair to say, right?
Yep.
So, but the compromising of one system could, compromise all of them. So my question to you is, how many systems do I need to break into before I compromise your network? One. So pick the old legacy systems. Those are the ones that are easy targets. In the ways of the Sahara Desert, you always try to find the weak lamb, and you go after that. The tigers always go after the weak ones, or the limps, or the older ones, or the dying ones. Same thing in a hacking point of view. I want the path of least resistance. I want a big meal. I go after the weak ones. So here you go. Client wants to authenticate to a bunch of different devices here. So he's going to speak to the authentication service, and that authentication service will provide access to things like file servers, mail servers, databases, or anything else that's on the network that is in the directory. So how Kerberos works. There's the client, and then there's the server. So let's see. I want to play a game.
Okay.
I'm going to give you guys a little bit different of a Kerberos. I kind of simplified it and put it in layman's terms because people had asked me to do that at one point. So the question came up of, well, how do you make Kerberos easy? And I used an analogy. I used the analogy of a carnival. So in this case, let's make a carnival. This would be the fence of the carnival. Okay? Write this down. I want you guys to draw this as much as I'm drawing this. So this would be the boundary of the carnival, or the security boundary. In Windows terminology, we call that a domain. Write that down. In Kerber's terminology, we call it the realm. There's your realm. Can you guys still see that?
Mm-hmm.
All right. So that's your realm. In my carnival, we're going to have a booth, carnival booth. That's going to be my booth. So you want to get in the carnival, you have to go to the booth first. You want to get into a network, you got to get authenticated. So this booth is going to be the authentication service. So we know, based on what we spoke about yesterday, that first you need to present your credentials, you need to identify yourself, then it needs to be proven. The authentication server is going to do that. And this is a complete ticket-based system. So in this carnival, there are also tickets. I know what you're thinking, that's a pretty cool ticket.
It is.
Except my ticket gets ripped in half. It's a ticket-based system. Then you're also going to have a user. Users are called principals. Write that down. Principals, or it's easier for me to go people. So we got a ticket-based system, we've got peoples, we got a security boundary called a realm, and then we have the authentication server. Well, because this is a complete ticket-based system, the authentication server also is a key distribution center, or a KDC. Key distribution center. It's also going to have that role. And a couple of things I want to put here. First, we need to identify. Second, we need to authenticate. Third, we need to authorize. And the whole time, we should be auditing. Agree or disagree?
Agree.
All right. The next two things that tend to be tricky for people is the ticket granting service and the ticket granting ticket. But I'm going to make that relatively easy for you. Before I do that, let's go ahead and make ourselves a Ferris wheel. So we're going to draw a Ferris wheel here. I know you're thinking it probably looks like a hamster wheel, but it's a Ferris wheel. It's got some stilts here. Okay, so that's the object in the domain. So user wants to log in. They've got to get authenticated. They supply their identity. They authenticate to the server, and then they're going to get authorized to use the resource. Would you agree or disagree with this?
Agree.
So far, so good, right? And it's all going to be based off the tickets, just like a carnival is. All right, so let's figure out what this ticket granting service is, a ticket granting ticket. All right, just like any service on a network, the service has to be available for you to use it. So if you want to do DNS lookups, there has to be a DNS server somewhere. If you want to do WINS lookups, there has to be the WINS service. You agree with that or disagree with that?
Agree.
All right, so we know that the service has to be available for the users. So now this ticket granting ticket. How does a ticket grant a ticket? Well, when you authenticate, you get an authentication ticket. You basically get permission to be inside the carnival. That's an authenticating ticket. That ticket gives you the ability to get authorization tickets. And that's your aha moment. So it's a ticket that gives you the ability to get more tickets. It's an authentication ticket that gives you the ability to get authorization tickets. Ticket granting ticket. So in this case, I need one ticket, my authentication ticket, to get inside the carnival, but every time I want to get on a ride, I have to get a new ticket. Every time I want to get on a Windows resource, I have to get a ticket, or a Kerberos resource. I have to get a new ticket, an authorization ticket. So am I authorized to get on the ride? but it's an authentication ticket that gives you the ability to get an authorization ticket. Yes, no, maybe so.
Yes.
All right. In this case, write this down. Your tickets are encrypted with DES. Or used to be anyway, but for now they're encrypted with DES. So there's a little bit of symmetric security here. That's good. Also, your tickets are time-stamped. In the carnival analogy, when you go to the carnival on Friday, you get a yellow ticket. When you go there on Saturday, you get a blue ticket. When you go there on Sunday, you get a red ticket. Why do they do that?
So you're limited to that day.
Right, so it's session-oriented and time-stamped. So you can't replay something from the previous session. And what's cool about this ticket is that it's broken in half. So when you actually go to your authentication service to get a ticket, half the ticket gets handed to the user, and then the other half of the ticket goes to the resource. That way when the user goes to the resource, they match up those tickets, and they go, oh, okay, hey, I've been expecting you. And that's kind of a cooler feature than a traditional carnival. But there's really no countermeasure against replay attacks. What happens if I find your ticket in the carnival and I pick it up and I go to the ride and they match it up and go, okay, hey, yeah, these match just fine. In the carnival analogy, they're just going to let you ride on. Same thing with the in the Windows environment. I'll just let you ride on. If you use somebody else's credentials, you're them for that session. Agree or disagree? Yeah.
Excuse me,
Go
before we
ahead.
go further, you said TSG is ticket granting service?
Ticket granting service.
And what about KDC?
Key distribution center. In what's hard with this analogy, or any analogy really, is that with the authentication service, the key distribution center, the ticket granting service, and the ticket granting ticket are all in the same box by default. So you think to yourself, well, how can this one device provide all of these roles? But they really are isolated components of Kerberos. In a complex environment, you could have one server for each role if you wanted to, and which is actually a problem with Kerberos, because what happens if the ticket booth goes down?
Nobody can get in.
Nobody's getting on rides. The same thing happens on a network. If you don't build in fault tolerance, clustering, redundancy, or any of the availability terms, then you don't get to play. If Active Directory goes down, or Kerberos goes down, nobody gets on any rides. So your authentication service has to be available. And if anybody's seen a domain controller go down during log-on times, you'll know what I mean by that.
We had a similar issue where we have server certs on
Mhm.
the components that make up this program that we work, and it doesn't use DNS, it uses hard-coded IP addresses, and so it points to a certification revocation
Mhm.
list or whatever. Well, they brought it down or changed the IP address on it and didn't notify the users, and
That'll
so
do it.
essentially the system shut down because it couldn't go out there and verify
Yeah, it couldn't prove you are who you say you are. But in this case, it was just trying to find the revoked list, and you couldn't find the revoked list, so it couldn't prove it that your ticket was revoked, so it crashed. Yep, exactly. So in this case, is Kerberos pretty easy? If you think about it in terms of a carnival, you can take the same keywords and terminology and overlay that to the network. But if you cross-reference to the carnival, so if I speak this talk in technical talk, everybody's gonna be like, "What the?" If you're not technical, you're not gonna appreciate it at all. But if I show you something that everybody's been to, everybody understands a carnival. We've all been to a carnival at some point in time. It's real easy to understand the players, and then you can convert that back to the technical speak. So you still have users of a network, you still have resources of a network, you're still going to have authentication services. You're still going to have, in this case, Kerberos is a ticket-based system. It just happens that a carnival is a ticket-based system. Also, you can brute force this as much as you want. You can try to go to the resource and say, I want to get on. And the resource will say, no. And then you can say, I want to get on. No. I want to get on. No. I want to get on. No, I want to get on. No, it's kind of like, hey, Mom, are we there yet, You'd have to build in something called a clipping level, which is a threshold of failed log-on attempts. Because by default, Kerberos will just let you keep trying to log on. Write that down. Clipping level is a threshold of failed log-on attempts. We'll get to it eventually, but it's a good point to cross-reference it here. Clipping levels is a threshold of failed log-on attempts. So how many times do you want somebody to try to log on before you say, you know what, wait 30 minutes? which in the professional world, that means go get a cup of coffee. My accountant's locked out again.
The safe word is 3.
I know some people that do that every morning. They just lock out their account so they can go get a coffee break. Just joking. Wouldn't surprise me though.
What a good idea.
All right. So, and again, we've taken a complex subject and we've broken it down in the layman's term, and now let's convert it back into tech talk. All right. So you want to log on. This means that you have to go to the ticket booth. You have to go get a ticket from the ticket center, the key distribution center, the person giving out the keys to the network or the keys to the car. Then eventually you're going to want to get on resources or the Ferris wheel. So you got to get a ticket granting ticket. Ticket granting ticket is a ticket that gives you the ability to get more tickets, or an authentication ticket that gives you the ability to get authorization tickets. And then eventually you can get to your resource.
So are those, when you talk about KDC, is it symmetric key, asymmetric key? Is it like a certificate?
What?
Your KDC.
Neither. Because it is, the ticket-based system is not symmetric or asymmetric. However, the ticket in itself is normally encrypted with a symmetric algorithm. Typically DES, triple DES, or AES.
Okay, you said.
So there's a component of symmetric in there, but it's not a symmetric-based system.
Okay.
But there are other ones like, I think it's the diameter off the top of my head, which is basically you can overlay the same carnival analogy, but with PKI, and then it becomes an asymmetric system.
Okay.
But you would get so much more scalability with that. Although people don't, not that I know of, don't really run into scalability problems with Windows. So I say that, but then I got to ask you: you ever known anybody that run into a scalability problem with Windows? No, me neither. And it's a ticket-based system. But in the traditional sense, a PKI-based system where you could just use your CAT card, ideally that would be better
So
because of the non-repudiation piece.
what are the credentials here? When it says sends credentials in order to get the ticket granting ticket?
Typically, you use your ID and password in the generic sense.
And the key distribution center is gonna validate
Right.
that? Or-
Well, if we go Active Directory for a second, the key distribution center uses the security accounts manager, and then it's just your plain username and password. But you can overlay this whole scenario with PKI, so it could be your certificate database instead of your SAN.
Like when you register the CAC, it actually
Yeah,
registers.
exactly. So you're using your CAT card to authenticate. So you can overlay this. Exactly. But I had a thought. Let me think of my book. I had a question. I don't know. You made me think of a thought. No, I'd say it was in one ear and out the other.
Now,
I lost it.
when you say receive service ticket, there's some sort of a authentication that happens again that gives you authority to go to that resource. So the
Well,
fact that I have a ticket granting me access to the system does not necessarily mean I have access to everything on the system.
Oh yeah, right. You still.
So I have to, it's really, it's not just, it's actually a.
What do you authorize to do?
authentication of what I'm, yeah.
You split the authentication and the authorization here. So what do you authorize to do? Are you authorized to read the server?
Right.
Write to the server? Do you have full control over the server? Do you have no access to the server? Either way, you still have to get authenticated before you get authorized to do anything. So your question yesterday was, can you get successfully authenticated and have no access? You have to do that. You have to get successfully authenticated. So with the whole Carnival example,
Right.
you can do it once for authentication, but when it comes to authorization, you might not be able to get a ticket for that server, if you will, because it's just an object in a directory, because you have no access. And that is certainly a valid point.
Aren't your access levels communicated to the resource by the KDC through half of the ticket that the KDC sends to the resource?
Yes. Right, exactly. So we're going to get into some access control models here. And what I have found over the years is that people routinely screw these up.
Yep.
Yeah.
Maybe it's because they're abstract, they're conceptual models, and so I'm going to make it really easy for you because we're going to play the keyword game. And with keywords, we can make this a whole heck of a lot easier. But we still have the subject, or myself, and then the object. So you still have to think of that, and we're going to control the access through that. And we can do that in a mandatory way, a discretionary way, or a role-based way. So let's jump into it. Discretionary access control. Keywords, let's do keywords. In this case, the data owner is responsible, or not responsible, but determines who has access. So the data owner has the decision-making power. So if I say Len, can I have that highlighter that you're holding? Do you have the ability to say yes or no?
Yep.
So he has the discretion. Gary, can you close your book for me?
Yes.
He made that decision. The decision making is yours as the user. This typically is similar to a work group environment or a very small network where the users have the power to make the decision. Can't really scale this too much because, well, that could get chaotic real quick. If everybody's making their own decisions, you can see how that it could be a little bit more difficult to manage. But the owner of the information, the owner of the book, the owner of the highlighter, they have the ability to make the decision. Write this down. This is typically used in a non-high secure environment, so not a DoD environment. So your little office of 10 people that are just doing file-based sharing between each other, that is discretionary. So everybody has the ability to make their own decision on who gets over. Non-high secure environment. And I know what that look means from now on, so you feel free to give me the look. So how do we do this in a small work group environment? How do I get the file to you?
Well, in Windows, you're going to put security permissions.
Yeah,
on
share
it
it,
for,
basically
yeah.
share it, right? And you have your NTFS permissions and your share permissions, but I'm basically just sharing it to you. And so if you were to right-click your folder or file, go to the security tab, you would be looking at an access control list. So write that down. The decision-making is enforced through an access control list. Piece of cake so far, right? Because I'm relating it to something that you know. Everybody here shared a file at least one point, I hope. So non-high secure environments, enforced through access control list. The data owner has all the decision-making power. Your keywords for Mac and role-based are slightly different. So you can get these questions correct because of the keywords. And literally, when it comes to these questions, like I just scan for keywords, and if I see things like access control list, my answer is DAC. It's that simple. If I see something like clearances or classification, I know my answer is going to be mandatory access control, and I don't even glance at the question more than a second to figure that out. And I could look, here's a trick for you. You look at your answers first, like I've been telling you to do, and if you see RBAC, MAC, and DAC, you go up to the question and just start picking out keywords. You start seeing clearances and classifications and device labels. Those are keywords for Mac. So your answer has to be Mac. So overview of Mac. So you have a data owner here. It's going to have some files.
Excuse me, say Mac or DAC?
What did I just say?
Mac.
If the keywords are clearances and classifications and device labels, data labels, security labels, those are going to be mandatory access control
Right.
keywords.
You click to the next page and said, I'm going to go more into Mac.
I'm sorry, DAC. And this page, this slide, we're DAC. Sorry for the confusion. So DAC, you got your data owner here, and he's going to have access to a printer, and he wants to share that access. So what he does is he goes to the access control list, goes to the security tab, and actually adds in who can do what. But the data owner has the ability to make the decision here, which is different from mandatory access control. Think of your clearances and classifications. If you have a top secret document, can you just decide who you want to give it to?
Nope.
Why not?
Need to know.
Well, for one thing,
Well, let's say you determine that, oh, you think somebody needs to know that. Can you just give them the document?
You don't know that they hold the clearance.
Oh, okay. So how do you enforce that? How do you know? What are you going to do? So I want to prove that you have a clearance before I give you my top secret document.
You have to go to somebody who knows. You have to go to an authorized entity that knows.
Oh, okay, so there's an authorized entity between that. So I, the user, now can't make the decision, is what you're saying.
If I don't, yes, if I haven't, yes. That's what I'm saying.
Right, exactly. And that's exactly what you have with mandatory access control. All of the access is done through security labels. Write that down and circle that. Now, I don't care what type of label. You see the word label, jump for joy. It could be security labels, device labels. If it ends in label, we're talking about MAC, mandatory access control.
Metadata tagging.
That's a little different. Nice try though. Security labels. So you have to basically attach the security label, and I've even seen cell phones now with a little unclassified piece on it, and it's like, come on, these guys are going crazy with the labels here. And they're color-coded, which I call idiot proofing. But access is granted or denied based off of the labels. So the way that the labels work is your clearance has to equal that of your object or dominate it. So if you have a secret clearance and you have a top secret document, your clearance has to be equal to or greater to access that. So because they're both secret, you can access it. Or if you had a top secret clearance and there was a secret file, you could access it because your clearance dominates that of your object. So your keywords here are going to be clearances and classifications. Right? Make sure you got those two keywords. If you see clearances and classifications, you have to be having a MAC conversation. Subject has the clearance of secret, or the object has the classification. So the classification has to deal with more of the objects, and the clearances has to do more with the subjects. So the object has a security label of top secret, for example. And so in this case, if the subject, Leo, has a secret clearance, but there's a top secret document, can I access it?
No.
Why not?
Because you're not equal to or greater than.
I'm not equal to or greater, and that's what we're getting at. So in this case, you have a user with a clearance, you have the classification, and then it gets mapped out to the actual resources. So there's really a whole system in between the user and the resources, well, the user and the resources. It's just that simple. So now the user, see, the difference between discretionary and mandatory? Discretion. But I used the combo word there. That was discretionatory, which I think is like mandatory. It's a combo word. It's the hybrid system. A user has a clearance, right? So in here, the decision making was with the user in discretionary. But what we do with mandatory is we have a system in between, and then the system controls who can access objects between